Years ago, microcracks were discovered on the surfaces of unused bridge girders located at the state's precast concrete plants. Those same cracks were also found on some of the bridges where the girders had been installed. But why? And could this lead to more cracking and shortened service life of the bridges?
It didn't look like there was necessarily a pattern to when this cracking occurred and when it didn't. And so we looked at different seasons, we looked at time of day, we looked at temperatures, we looked anything you can imagine. Finally got to the point, I was like, well, just looking and trying to figure out the pattern wasn't going to resolve it. So we started needing to take some cores, get some, study what exactly going on.
So one of the main questions we had is that we know if you just had a single microcrack, that is not really going to cause an issue. But what happens when you have many cracks? So what is the effect of crack density when you're looking at microcracks? So we did the field studies in which we're monitoring in-service girders over time. And then we also augmented that with some laboratory studies in which we cast concrete mixtures. We subjected those concrete specimens to accelerated weathering tests by subjecting it to moisture as well as simulating a marine environment. And we developed a model to predict how these cracks will grow over time, and more importantly, how they may impact the strength as well as the corrosion resistance of the concrete.
So if these cracks get deep enough or wide enough to allow water in, and chlorides and things like that, and gets to the reinforcing steel, that's going to quickly deteriorate the bridge. And so that's the biggest thing we're trying to avoid.
We found that depending on the nature of the microcracks, that it could impact the service life between 2 to 13 years. So that means a 2 to 13 year reduction in the overall service life of the bridges. So our major recommendation for TxDOT is that in terms of monitoring, additional monitoring is needed, particularly towards the very end of the service life of the bridges.
We believe the cause of the cracking was related to shrinkage. Now, why it's shrinking more than what it had prior to that period, we're not quite certain of that. We think it may have been coincidental with the big drought we had from 2010 to 2015, because towards the end of that sort of drought is when we started noticing some of this cracking. And so we believe that played a role. The environment, in fact, that's what the research said, was environmental impact does play a significant role in how much cracking is going to occur.
We already have really good specifications about how a single crack is going to impact strength and it's going to impact corrosion resistance. What we didn't know is how many small cracks are going to affect it. That's really where we had this gap in the research, the gap in the science. And what this project really showed is that, yes, if you had one little microcrack, that's not going to make a difference. But if you do have many microcracks, the density of those microcracks can actually exacerbate the problem and impair long-term durability.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.